Okay, students, if you look at this page here, you only have one page and there's only 5 problems on it. So I'm not going to do any of these exact problems. I'm going to make up ones and put it on the next page as an example for you. I will just tell you an example in problem 1 here. You could factor that and come up with your 2 factors and plot those 2 zeros and do your graph from there. Number 2 does not factor, so you're going to put that in the graphing calculator, and I'm going to show you an example of each of these. Okay, on the next page, and I'll make up one. Okay, so here's one like example 1. If I have x squared minus 4x minus 32 equals 0. Okay, this one factors. Remember, it's going to, since leading coefficient is 1, a times c is negative 32. It multiplies to negative 32 and adds to negative 4. What are those 2 numbers? Negative 8 and positive 4. Square root of x squared is x, so it's x and x. 1 is a minus 8. 1 is a plus 4. That's equal to 0. Set each factor equal to 0 now. So I get x equals 8 there, and x equals negative 4 for the second one. That means these are my 2 solutions, also called roots, also called zeros, also called x-intercepts. Okay, so x-intercepts, solutions, roots, what did I say the fourth one was? Now I just lost it. X-intercepts, roots, solutions, zeros. Okay, these all mean the same thing. You need to memorize all 4 terms. What it means, obviously, is the x-intercept, where it crosses the x-axis. Across the x-axis at 8 and negative 4. So if I was to plot it, 8, 1, 2, 3, 4, 5, 6, 7, 8, and negative 4. It crosses there. Now, to find the x-coordinate, let's change the color. X-coordinate of vertex is always x equals negative b over 2a. Remember, this is ax squared plus bx plus c equals 0, standard form of a quadratic. So negative b is negative of negative 4 over 2a. 2 times 1 is 2. So I get 4 over 2, which is 2. So the x-coordinate is 2. That formula always works, or expression. The other way is I just take the midpoint of 8 and negative 4. How far from 8 to negative 4 is a total of 12. What's half of 12? 6. So I can go back 6. 1, 2, 3, 4, 5, 6. And there's my 2 where I go forward 6. 1, 2, 3, 4, 5, 6. So there's the 2 for the x-coordinate. Okay, now I also know that this is a positive 1x squared, which means the vertex has to be, the parabola itself opens up. Okay, which means the vertex is somewhere down here. Okay, so it opens up when I connect it. Now, how do I get the y-coordinate? I plug that 2 into the equation itself. I can plug it directly into here, or I can just plug it into those 2 and multiply those 2 together. And that's usually easier. So what is 2 minus 8? Negative 6. And what is 2 plus 4? Positive 6. So what is negative 6 times 6? Negative 36. So way down here, 2 negative 36 would be my vertex. This is called the vertex of a quadratic. Okay, so if I plug the 2 into here, I'd have 4 minus 8 is negative 4 minus 32 is negative 36. If I plug it in here, I get the same answer. Okay, so 2 negative 36, And then I just go ahead and curve this out here and put arrows at the end because it goes on forever. And there's my parabola. That's graphing it. Remember, these where it crosses the x-axis called the x-intercepts, roots, zeros, or solutions. So going back to this here, solve each equation by graphing. If exact roots cannot be found, we found exact roots, 8 and -4 in that example. State the consecutive integers between which the roots are located. So you technically didn't have to graph it at all. You know, that 2, -36 wouldn't plot on here. You just need, for our example, you just need to have the 8 and the -4, because that's what you're looking for, is where it crossed the x-axis. It's called the. Okay, now let's do an example where you can't factor it and you use the graphing calculator. So let's go to the next page. So here's one like example 2, or problem 2 in your homework. -x² plus 3x plus 5 equals 0. Okay, now there's ways of doing it by hand. We're not at that level yet. We do that in Algebra 2. Okay, we're just going to have you plug in the graphing calculator. This does not factor, so I can't do it like number 1, but I still need to find, in the next sheet, you're going to do it with quadratic formula. So here we're just doing it with the graphing calculator. So pull up the graphing calculator, clear it, and I go ahead and go to my y equals, type it in, negative. Notice I have to use the negative sign, not the minus sign. For the very first term of my equation, if it's a negative, I have to use the negative button as I did there. Negative, x is right there. Squared button is right there. Plus 3x plus 5. Hit enter. Notice the equal sign is highlighted. That means it will graph that equation only. So even if I put something else in here and hit enter now, and you see how that's highlighted? If I go back on top of that equal sign, hit enter. So even though that 56 is in here, it's not going to graph it because I unhighlighted the equal sign. It will only graph the equations that are highlighted with the equal sign. Just so you know that, if you didn't know that already. All right, so now we can hit graph, and it graphs it there for us. Okay. So remember, we're trying to find these two spots where it crosses the x-axis. Okay. So now how do I do that? Well, first off, going back to the question itself on your assignment, it says if it's not exact roots, which ours aren't, find the consecutive integers between which the roots are located. So I can already look at it from a graphing calculator and see this left one is between -1 and -2. That'd be my one answer. And this one, 1, 2, 3, 4, between 4 and 5 for the second one. Okay. So that's what they'd be asking, between -1 and -2 and between 4 and 5 are my two answers when I'm doing an example like this one, your number 2 problem. But we're going to go ahead and show you how you actually find the answer rounded. Okay. We're trying to calculate something. So you see this trace button next to the graph, you see right in blue, it says calculate. That's what we want to do. We want to calculate something. We want to calculate, remember one of those terms that we called where the x-intercepts, on the graphing calculator, they call them zeros. That's why you have to know the term. And now it says left bound. Doing it this way, which is a little bit longer. I'll show you this way and then I'll show you the quicker way. Left bound means put the cursor to the left of the answer. That is to the left of the answer, hit enter. Now put it to the right of the answer. And my root is somewhere in between there. Hit enter again. And you see it says 0 is -1.19, etc. Okay, so again, between -1 and -2, as I said, that'd be the approximate answer, -1.2 if you're rounding to the nearest tenth. To do the second one, I'm doing the 0 again. So I just move it over closer, hit the right arrow as you see me doing here. See, so that's to the left of the answer. Now I go to the right of it. Doesn't matter where. That's to the right of it. Hit enter, and it'll pop it right back up there. And you see it's 4.19 or approximately 4.2 if you round to the nearest tenth. Again, that's between 4 and 5. Okay, now let's say we want the vertex. Remember, the vertex is right here at the top. And so that's called a maximum. The vertex is either a maximum or minimum for all parabolas. That's the name of the curve for the quadratic. And so since it opens down, it's a maximum, not a minimum. If it opened up, it'd be a minimum. To find that, we want to find the maximum because we have to identify it as a maximum. Yes, it is a maximum. Go to the left of that maximum. So left arrow past it. Somewhere to the left, that's the left. Now go to the right and hit enter, and it'll pop right there at 1.4999. Just so you know, when you have 9999 like that, that really means the next one up, so it's really 1.5 exactly. Okay, so you wouldn't write 1.49 repeating bar, it'd be 1.5. Okay, and remember, we can get that from negative b over 2a. So going back to our equation, negative b is negative 3 over 2a, which is negative 2. And negative is positive. 3/2 equals 1.5. Okay, so you can see what I was saying is correct. It's 1.5 exactly, not 1.49 repeating bar. Just be aware that if it's 0.9 repeating bar, that really means up to the next one, 1.5. Okay, I could prove that algebraically to you, but I'm not going to do that for this lesson. If you want to know, you can ask in class and I'll prove it to you on the board. All right. So let's go back. And we answered how to do those. Now let's go down to here. The roots, remember, another word for our solutions, our roots are zeros or x-intercepts. Now they're using the word root here. So again, you're practicing the different names of the same thing. The roots of the quadratic equation are given, negative 2 and 0. It's a minimum at negative 1, 1, negative 1, negative 1. So that means that's the vertex. Okay, it looks like this. Graph the related quadratic function if it has the indicated maximum or minimum point. Okay, and that is a minimum. Okay, so we're just practicing graphing it. Oh, I did that problem for you. Okay, I'm not doing the other two. Okay, that'll go ahead and end it. 12 and a half minutes.